Okay, my friends, we are going to set out to solve exponential and logarithmic equations. When we look at this first one, you always want to locate where the variable is first. So the variable is in the exponent. So then I want to look at the base numbers, and I want to see if there's any way to make the base numbers the same base. So I am reminded that 16 is really 2 to the 2, 4, 8 to the 4th power. And 8 is really 2 to the 3rd power. So I can rewrite this problem. I can rewrite 16 as 2, oh my goodness, as 2 to the 4th power. And then there's also a 3x. And then I can make the 8 2 to the 3rd power. So if you lost track of what I did, I took this whoa, hello, so large. I took this 16 right here and rewrote it as 2 to the 4th power. I leave the 3x right where it was. And I took the 8 and turned it into 2 to the 3rd power. And I did that so that I would have the exact same bases. I did that so that this number right here and this number right here are the same number. And I did that because if those two numbers are the same number, then they will undo each other. So then I am left with the problem 4 times 3x is equal to 3, or 12x is equal to 3, or x is equal to 1/4. And that will do it for me. If I want to check myself, I can probably type that in my calculator and hit enter, and I find out that I get 8. Okay? All right. When I look at this problem, I notice again that x is in the exponential. But this time when I look at the 5 and the 130, there is no way to take 5 to any power and get 130. That doesn't work. So because that doesn't work, I then am going to turn it into a log. So I'm going to take my exponential equation and turn it into a logarithm. So I'm going to say I have a logarithm whose base is 5, whose argument is 130, and it is equal to 2x. Again, I'm not sure how my ink pen got so fat. X is not by itself yet, so I'm going to divide by 2. That's the same as multiplying by a half. So now that x is by itself, I'm simply going to grab my calculator, and I am going to put in my calculator this exactly the way it is written. So by the way, that is the exact answer. So the exact solution is 1/2 log base 5 of 130. Okay. The approximate answer is what you get when you type that into your calculator. When you type that into your calculator, let me type it into the calculator for you. I'll show you, I'll put it in, I will put it on here. I need to type it though, because I will never remember it. Okay, so if I put it in the calculator, let's see, what do I need to do there? I need to go out and open up Canvas. And I need to open the calculator. Grab the calculator. And I would type in on the calculator 0.5, math, arrow up twice. And I type in a 2, and I type in 130, and I hit enter. And let's say, are we going to go to the thousandth? I think we should go to the thousandth. So 3.5111. 3.5111. 3.511 will be my estimated answer. Okay. On this one, the variable is located inside the argument of the logarithm. So I'm going to change the logarithm from a logarithm to an exponential. I'm going to remember that this is a power of 10. It's a common log. There's no base shown, so the base has to be the common base. So the common base is 10. So this is going to be 10 to the second power is equal to 4x minus 3. That is 100 is equal to 4x minus 3. That is 103 is equal to 4x. That is 103 divided by 4 is equal to x. That is the exact answer. And there is no reason to do anything else to this problem. Okay, on this one, I notice that I have two logarithms joined together by a minus sign. So first I'm going to write it as one logarithm. So I'm going to say logarithm whose base is 5 is 6 divided by 3x is equal to negative 2. And then I would probably reduce my fraction. So log base 5 of 2 divided by x is equal to negative 2. Then, because my variable is in the argument of a logarithm, I'm going to change my logarithm to an exponent. So that's going to give me 5 to the negative second power is 2 divided by x. So that is 1 over 5 squared is equal to 2 divided by x. So that is 1 over 25 is equal to 2 divided by x. So that is x is equal to 2 divided by 25. Because I would multiply by x. Oh, and multiply. I'm glad I wrote that out because my answer is wrong. If I cross multiply, I get x equals 50. I think I'll check that. I think I will check that. So that's log 5, 6 minus, okay. So if I check that, I don't know why I just didn't use the one I had up, but I think I forgot I had it up. So that was log, I forgot already, 5, 6 minus, okay, log 5, 6 minus, math, arrow up, 5, what was it? 3 times 50. 3 times 50. And it should equal negative 2. Oh, it does! Look at that! So it worked. Yay! Alrighty. We're not going to check every one of them just because it takes too long. Okay. On this one, I notice I have a couple logarithms, but they both need to be on the same side of the equal sign. So the first thing I'm going to do is I'm going to take this and I'm going to move it over here. So that's going to give me logarithm of an argument 7x plus 1 minus a logarithm of an argument of x minus 2 is equal to 1. Then I'm going to notice that I have subtraction, which in logarithm is really division. So I have a logarithm of 7x plus 1 divided by x minus 2 is equal to 1. I then notice all the x's are in the logarithm, and I remember this is a common log. So this is really 10 to the first power is equal to 7x plus 1 divided by x minus 2. I multiply both sides by x minus 2. That's going to give me 10x minus 20 equals 7x plus 1. Now I have an algebra 1 problem. So 3x equals 21. So x equals 7. Yay! That wasn't bad. Okay. So locate where the x is. The x is inside a logarithm. The logarithm has a power of 2. So that power of 2 becomes the coefficient. So I have a 2 natural log of an argument of x minus 3 is equal to 4. And then I'm going to divide by 2. That's going to give me the natural log of x minus 3 is equal to 2. That's going to give me e to the second power is equal to x minus 3. That's going to give me e to the second power plus 3 is going to give me x. That is the exact answer. That is the exact answer. The approximate answer is the one you're going to get when you type it in a calculator. E squared plus 3. So grab our calculator, go e squared, make sure you get out of it, plus 3, 10, 3, 8, 9, 10, 3, 8, 9, 10, 3, 8, 9. So x is approximately 10.389. Okay, on this one I'm going to move the 2. So we're going to have 4 e 2x equals 14. And then I'm going to go divided by 4. I then have e to the 2x equals 7 halves. The variable is in the exponent, so I am going to change it to a logarithm. Yes. So that's going to be a natural log of 7 halves is equal to 2x. So then I'm going to divide by 2, which is the same as multiplying by a half. So I'm going to have 1/2 of the natural log of 7 halves is equal to x. That is the exact answer. Now when you go to approximate it, 0.5 natural log 3.5, 0.5 natural log 3.5, 0.5 natural log 3.5. It's going to be 0.626. 0.626. X is approximately 0.626. That's the approximate answer. There should be another P in there. Okay, on this one, the variable is in the exponent, and there is no way to make the base and this base the same. So I'm going to change it into a logarithm. I'm going to say I have a logarithm whose base is 4, whose argument is 3, is x minus 2. Then I'm going to add 2 to both sides. And that's going to give me 2 plus a log base 4 equals 3. Nope, hello. Sorry. 3 equals x. That's the exact answer, friends. When you're asked for the exact answer, that's the exact answer. The approximate answer is what you get when you type that in the calculator. 2 log 4/3. 2 log 4/3. 2 log 4/3. 1.585. 1.585. 1.585 is the approximate value of x. Okay, on this one I notice I have logarithms on both sides. Hello, I thought I was in highlighter mode. Logarithms on both sides. So I am going to take this logarithm and move it over there with the other logarithm. And I think I'll clean this up a bit. So this is log 3x squared, because this coefficient is the power of that. And then it would be minus, whoops, let's go back to black, minus log cube, or log base 3, 5, equals negative 2. So that would be log base 3 of x squared over 5 is equal to negative 2. So now, since the variable is in the argument of a log, I am going to change the logarithm to an exponential. So that is 3 to the negative second power equals x to the second power divided by 5. That's 1 over 3 squared is equal to x to the second power divided by 5. I think I'm going to take and also multiply 5 by 5. So that's going to give me 5/9 is equal to x squared. So that's going to give me the square root of 5 over 3 is equal to x. Ooh, that's kind of interesting. And it's not plus or minus because it's a logarithm. It has to only be plus. I'm pretty sure that's true. Ooh, that's exciting. Didn't know that would happen. All right. So how are we going to make up problems? Okay. I think to do this, I'm going to move the 6. That's going to give me the opposite of e 12x as an exponent, and that would be negative 0.8. And then I'm going to divide by negative 1, because I do not want those negative signs there. That's going to give me e to the power of 12x equals 0.8. And because the variable is in the power of, is in the base, is in the exponential, because the variable is in the exponential, I'm going to turn it to a logarithm, and it's e, so it's a natural log of 0.8 is equal to 12x. So the natural log of 0.8, I'm going to divide by 12, which is the same as multiplying by a 12th. So I'm going to have a 12th of the natural log is equal to x. That's my exact answer. My approximate answer is going to be 1/12 of the natural log of 0.8. So it's going to be 1/12 of the natural log of 0.8. Negative 0.019. Negative 0.019 is the approximate value of x. Okay, my friends, that is how you do those problems. If you have any questions, ask me in class or send me an email. Have a great day. Turn it off. Okay, where's the off? There we go. Thank you.